Good day everyone. Today I will apply 3 instructional technologies that can be used in teaching motion in physics. Before we proceed, let me check your prior knowledge about our topic today. First, motion is not relative, true or false. Second, distance and displacement mean the same, true or false. Third, speed and velocity mean the same. Is that true or false? Whatever your answer right now will be checked after our discussions. There are 3 objectives of the lesson. First, the students should be able to define motion, speed, and velocity. Second, measure the distance, displacement, and speed of a moving object. Third, describe the motion of an object in terms of velocity. How is motion defined? In these pictures, can we observe motion? Yes, there is motion. Why do I say so? It is due to the object's change of position. If there is change in position, there is motion. But how can we tell that the object changed its position? There we have the term frame of reference. A frame of reference is the reference point that are not moving in relation to an observer and things moving with the observer. In this figure, we say that the car is in motion relative to a tree, which is considered as a reference point or a frame of reference. Motion can be described in distance, displacement, speed, velocity, and acceleration. What do you observe on the given? Yes, we can see a number, a unit, and direction. If you categorize the given to distance, displacement, and speed, which belongs to distance, to displacement, and to the speed? Number 1, 250 meters is a distance. Number 2, 250 meters to the left is a displacement. And number 3, 250 meters per second is speed. In able for you to understand their differences, I will let you perform the first activity entitled Vector Walk. Vector Walk. Your goal is to describe the motion of an object in terms of distance and displacement, and determine the distance and displacement of an object. In order to do that, you are required or allowed to use your laptop, tablet, mobile phones, or other gadgets that can access to Google. Here are the procedures. In Google search engine box, open the website needed for this activity by typing in Vector Walk Interactive, the physics classroom. It seems like this one on the screen. Click the first link on the list to open the interactive activity. Then, in the website, click the Launch Interactive, like this one. And number 4, click Begin Activity. There will be 3 activities that will be accomplished, namely car in a parking lot, cross-country skier, shopping cart in aisle. In letter A, car in a parking lot, a car in a parking lot travels back and forth in an effort to find a good parking place. Tap the Start button to view the motion. Then watch carefully the movement of the car and record each car's movement to answer the questions that follow. 2.1. What is the overall distance traveled by the car? Then what is the overall displacement? Letter B. In the cross-country skier. A cross-country skier is moving back and forth along a golf course. Tap the start button to view the motion. Watch carefully the movement of the skier and record each skier's movement to answer the questions that follow. What is the overall distance traveled by the skier? And what is the overall displacement? For letter C, shopping cart in aisle. A grocery cart I push back and forth down an aisle of a grocery store. Tap the start button to view the motion. Watch carefully the movement of the grocery cart and record each grocery cart's movement to answer the questions that follow. The overall distance traveled by the grocery cart and the overall displacement. You are required to present your group outputs. And here are the answers on your activity. For activity number 1, the distance is equal to 130 meters. It is determined by adding up all the ground that was covered. That is, at the distances from A to B, B to C, to D, and then from D to E. This means one must add 40 meters, 45 meters, and 45 meters, which is equal to 130 meters. And the displacement is determined by simply measuring from the starting position, letter A, to the final position or the point E. And this is 40 meters directed to the right or positive 40 meters. For the skier, the distance is determined also by adding up all the ground that was covered. That is, at the distances from A to B, then from B to C, from C to C. This means one must add 60 meters, 45 meters, and 60 meters, which is equal to 165 meters. The displacement is determined by simply measuring from the starting position to the final position, from point A to point D. And this is 75 meters directed to the left or negative 75 meters. For the cart, the total distance covered is 95 meters, and the total displacement is positive 25 meters or 25 meters to the right. Distance is how far A from B point, and displacement is the straight line distance between 2 points. In short, distance is the total length traveled by an object, while displacement is the shortcut or the distance between starting position to the final position. Now we already know the difference between distance and displacement. We shall proceed to the next activity entitled The Moving Man. There are two objectives here. First is describe the position of the man using the graph with regards to the velocity, time, and distance. Second is to identify the relationship of velocity, time, and distance. Then the procedures are, number 1, we're going to open the program Java, The Moving Man. Then you are required to answer the 4 questions that is plotted, that is on your screen. Next step is you're going to set the velocity of the program based on the table below. Here is the table. You're going to find the position of the moving man using the time provided. Then, after getting the needed data, reset the program. Then input the velocity provided again. You are required to present your outputs per group. Then answers for activity number 2 are, for question 1, the initial position of the moving man is 0 meter. For question 2, the position of the house is 8 meters. For question 3, the position of the tree is negative 8 meters. And for question 4, the position of the house with respect to the tree is 16 meters to the left of the tree. And this is the completed table. For the time of 1 second and velocity of 2 meters per second, the position is 2 meters. For 2 seconds, that is in 4 meters. For 3 seconds, the position is 6 meters. And in 4 seconds, the position is 8 meters. So we already differentiate speed from velocity. Speed is described how fast or slow the motion is. And velocity is the speed of something in a given direction. In mathematical equation, speed is equal to distance divided by time. So that's why we have the unit meter per second, while velocity is equal to displacement divided by time. In short, velocity gives both magnitude and direction, and also called as a vector quantity, while speed is magnitude only, and this is called scalar quantity. So the concept of motion is qualified by two quantities, the scalar and vector. Scalar is always described by its magnitude. Example, the speed and distance. Then vector is described both by the magnitude and direction. And the example for that is displacement, velocity, as well as the acceleration. To check your understanding, let us have a fun games. You're going to use your mobile phones, or laptop, tablet, or any gadgets that can be used to access on Google. Only one gadget per group. And here is the procedure. On the search engine, type kahoot.com. Then click play. Choose team mode. Then name your team. To start the game, enter the pin as your teacher tell you. If you got the correct answer, this image will pop up on your screen. The teacher can monitor every scores of each group as well as the one who answers first, second, and so on. The group that got the highest score will win the game. Thank you very much.